In this video, I'm going to show you how you can locally install Tora, which stands for a Tool Integrated Reasoning Agent. Now, what is Tora? Tora is a series of tool integrated reasoning agents designed to solve challenging mathematical reasoning problems by interacting with tools. For example, computation libraries or symbolic solvers. This Tora series models seamlessly integrate natural language reasoning with the utilization of external tools, thereby mixing the analytical prowess of language and the computational efficiency of external tools. Right now, Tora Code 34 billion model is the first and only open source model to achieve over 50% accuracy on the maths dataset, which significantly outperforms even GPT-4's chain of thought result and is competitive with GPT-4 solving problems with programs. They have also open sourced their code and models, and then they are hoping to achieve more breakthrough in this. I will drop the link to this GitHub repo where you can read more about all this benchmarking, their source code, and a lot of other things, including their research paper, their website, Hugging Face model, and a lot of other things. Also, these models, the Tora models I mean, are trained on Tora Corpus 16K, which contains tool integrated reasoning trajectories of math and GSM 8K from GPT-4. They also use imitation learning or SFT to fine tune the models and then apply their proposed outspace shaping to improve tool integrated reasoning behaviors. You can read more information about it in the paper. I'll be using the blog's Tora 7b quantized version, which is present on this Hugging Face page, and I will also share the link in video's description. The file size is quite cool, around 4 gigs, so it should be good. You can install this model either on Windows, Linux, Google Colab, or even AWS SageMaker Notebook. I'll be using my trusted Google Colab notebook for this, and I'm using the T4 runtime, which is a GPU one. So make sure that you select the runtime type as T4 GPU and similar ones on your AWS EC2 instance if you are using that or any other system. If you want to install it on Windows, make sure that you use Windows subsystem for Linux in order to run the commands which I'm going to use. So let's get started. The first step we need to do is to install the prerequisite libraries, which are transformers and optimum. So let's run them. Shouldn't take too long. Let's wait for it to finish. Both are done. In the next step, let's git clone the GPTQ library because this is what is needed to use the quantized version. We have cloned it. In the next step, now let's cd to that directory, which is our auto GPTQ one. We are in that directory. Let's check out the stable version from this GitHub repo, which is version 0.4.2. That is nice. And now let's install it, which is simply our familiar command pip install dot. And this takes around 2 minutes. So let's wait for it to finish. AutoGPTQ is installed. Now in the next step, let's download the model from the blog's quantized version from Hugging Face, which is Tora 7b v1, and then use the auto tokenizer to generate the token. So let's run it. And the model size, as I mentioned earlier, is around just over 3 gig, I guess. So shouldn't take too long. Let's wait for it to start. So first it is downloading the config file, and then as you can see around 4 gig, 3.9 gig model is being downloaded. Let's wait for it to finish downloading. The model is downloaded. Now let's give it a complex math problem as a prompt. In this code chunk, I am asking it bit of a complex math equation that if 3x minus y is equal to 12, what is the value of 8 into x, 2 into y? And then I'm giving it a prompt template which is required by this model. And then I'm using auto tokenizer to generate inputs and then feeding it to the model which generates output, and then we feed it into the pipeline to print out the response of the model. So let's run it and see what happens. So I will let it run in real time so that you can also see the response time. So you can see how quick it was. And it has given us not only the solution of it, but also a program around it. It has run it and it has given us this output. And there you go. Now, um, this model, as I said earlier, is primarily geared towards solving the complex math problems. So feel free to give it complex problems like exponentials and even your SAT problems, SAT exam problems, so that and see how it goes. But if you want to install it, now you have the steps and how to do it. You can install it in Linux, in any version of Linux, even if it is hosted in WSL. I hope that you enjoyed it. If you already have tried it out, let me know how you go. And if you have any questions, please ask. And if you like the content, please consider subscribing to the channel. Thank you.